Humanity began reaching toward the stars long before a single rocket ever left the ground. It started with something beautifully simple, just looking up. Long before engines, satellites, observatories, space stations, or telescopes, human beings lived beneath skies much darker than the skies most of us know today. At night, when the fires burned low and the world became quiet, the heavens opened above them with a depth that must have felt endless. There were no electric lights hiding the stars, no cities glowing on the horizon, no clocks, no screens, no photographs of galaxies, no maps of the universe. Only the night, and above it, thousands upon thousands of points of light. To the earliest humans, the sky was not empty. It was alive with motion. The sun rose and fell. The moon changed shape. Certain stars appeared in one season and vanished in another. Some bright points wandered slowly against the background of fixed stars. Eclipses came without warning. Comets appeared like pale ghosts in the darkness, and then disappeared again into the unknown. At first, the sky was mystery. Then slowly it became memory. People began to notice that the heavens repeated themselves. The moon did not change randomly. The seasons returned. The sun's path shifted across the year. The stars moved in patterns. What seemed at first like a silent, unreachable chaos began to reveal rhythm. And from that rhythm, the first astronomy was born. The stars helped travelers cross deserts, oceans, forests, and open plains. The moon helped people measure time. The sun helped farmers know when to plant, when to harvest, and when to prepare for winter. The sky became a clock, a calendar, a compass, and a sacred mystery all at once. Ancient civilizations built their lives around it. They raised stone circles, aligned with sunrise. They built temples where light entered on special days of the year. They watched shadows move across the ground. They followed the moon's cycle, tracked the planets, recorded eclipses, and passed knowledge from one generation to the next. They could not travel to space, they could not leave Earth. But in a quiet and patient way, they were already trying to understand the universe. They were listening to its heartbeat, and that is where the story begins. Not with a launch, not with fire, not with machines, but with human beings standing beneath the night sky, wondering what was above them. For a very long time, the heavens seemed unreachable. The stars were too far away to touch. The moon was a silver light in the darkness. The planets were wandering lights that moved in strange paths. The sky looked like a dome placed over the world, something perfect, distant, and eternal. Then came the thinkers who began asking deeper questions, not only where the stars were, but what they were. Ancient philosophers argued about the shape of Earth, the nature of the heavens, and the place of humanity in the universe. Some imagined Earth as a sphere. Others tried to measure its size. They studied the movement of planets and created models to explain what they saw. For centuries, one idea dominated much of human thought. Earth was the center of everything. In this view, our world sat still and unmoving, while the sun, moon, planets, and stars turned around it. It felt natural. It matched what the eyes seemed to see. Each day the sun rose in the east and set in the west. The ground beneath people's feet did not feel like it was moving. Earth felt solid, central, important. But the sky kept leaving clues that something was wrong. The planets did not move in simple circles. Sometimes they seemed to slow down. Sometimes they appeared to stop. Sometimes they moved backward against the stars before continuing forward again. To explain this, Astronomers created more and more complicated models, adding circles upon circles, trying to preserve the idea that Earth stood at the center. The system worked, in a way, but it was not simple, and the truth was waiting. Then came Nicolaus Copernicus with a quiet but radical idea. What if Earth was not the center? What if Earth was one of the planets? What if it moved around the sun? Today, that idea feels familiar, almost obvious, but at the time, it changed everything. It moved humanity from the center of the cosmos and placed us on a moving world, circling a star inside a much larger system than anyone had imagined. It was not only a scientific change, it was a psychological one. The universe became bigger, and humanity became smaller. But at the same time, human understanding became stronger. Then Galileo pointed a telescope at the sky. That moment was one of the great turning points in history. The telescope did not carry anyone into space, but it carried human vision beyond the limits of the naked eye. Galileo saw mountains and shadows on the moon, proving that the moon was not a perfect, smooth sphere. He saw moons circling Jupiter, proving that not everything revolved around Earth. He saw the phases of Venus, supporting the idea that Venus moved around the sun. He saw countless stars hidden in the Milky Way, stars no human eye had seen clearly before. The heavens were no longer a perfect, untouchable realm. They were places, real places, worlds with surfaces, shadows, movements, and laws. Johannes Kepler studied planetary motion and discovered that planets do not move in perfect circles but in ellipses. Isaac Newton later gave humanity the language of gravity. He showed that the same force pulling an apple toward the ground also held the moon in its orbit and guided the planets around the sun. Suddenly, the sky was not magic. It was not random. It followed rules. The moon was not simply hanging above Earth. It was falling around Earth, endlessly missing the ground because of its forward motion. Planets were not carried by invisible crystal spheres. They were moving through space under the influence of gravity. This was a profound shift. Space was no longer only a dream or a myth. It became a problem that could be calculated, a place that could be measured, and maybe, one day, reached. But knowing the laws of the heavens was not enough. Humanity could understand the moon, but still could not touch it. We could predict the movement of planets, but still could not travel to them. We could look deeper and deeper into the sky, but our bodies remained bound to Earth by gravity. To leave Earth, humanity needed something powerful enough to climb out of the world. It needed a rocket. The idea of rockets is much older than modern spaceflight. Centuries ago, in China, powder-fueled rockets were used as fireworks and weapons. They were simple compared to the machines that would come later, but the basic principle was already there. Hot gases rushed out in one direction, and the rocket moved in the other. For a long time, rockets remained tools of war, celebration, and imagination. They were unpredictable, dangerous, and limited. But hidden inside them was the basic secret of space travel. A rocket does not need to push against the air. It pushes against its own exhaust. That one idea matters more than it might seem. An airplane needs air. A bird needs air. A propeller needs air. But space is almost empty. There is nothing to push against. If humans were ever going to travel beyond the atmosphere, they needed a machine that could work in emptiness. The rocket could. At the beginning of the 20th century, a small number of visionaries began to understand what that meant. Konstantin Tsiolkovsky imagined spacecraft, orbital stations, and a future where humanity might spread beyond Earth. He thought seriously about rockets. Long before rockets seemed practical, he understood that liquid fuels could make them far more powerful. He imagined stages falling away as a spacecraft climbed higher and higher. Robert Goddard, working in the United States, launched liquid-fueled rockets in open fields. His machines were small and fragile, but they were real. He was often mocked in his time because the idea of reaching space sounded impossible to many people. Hermann Oberth wrote about interplanetary travel and inspired a generation of engineers and dreamers. At the time, much of this sounded like fantasy. Space travel belonged to novels, not laboratories. But the mathematics was real, the physics was real, and slowly the dream moved closer to the machine. Then history took a dark turn. During the Second World War, rocket technology advanced with terrifying speed. Germany developed the V-2 rocket, the first large ballistic missile capable of reaching the edge of space before falling back to Earth. It was not built for discovery. It was built as a weapon. The V-2 rose higher than any machine before it, but it carried destruction. It showed that rockets could leave the lower atmosphere. It showed that powerful engines, guidance systems, and long-range ballistic flight were possible. But it also showed the painful truth that many technologies are born not only from curiosity, but also from fear, war, and violence. When the war ended, the V-2's technology, records, factories, and engineers became part of the foundation for the space programs that followed. The United States and the Soviet Union both understood that rockets would define the next era. At first, those rockets were not imagined only as tools for exploration. They were also delivery systems for weapons. The same machines that could place satellites into orbit could also carry warheads across continents. And so, after the war, the world entered a new age, the Cold War. Two superpowers stood against each other, the United States and the Soviet Union. Their competition spread across politics, science, military power, technology, culture, and ideology, and soon it reached space. The space race began not as a peaceful adventure, but as a contest of power. If one nation could launch objects above Earth, it could show the world that its science, engineering, and military systems were superior. Space became the highest stage on which human rivalry could play out. The first great milestone was surprisingly small. On October 4, 1957, the Soviet Union launched Sputnik 1. It was not a large spacecraft. It was a polished metal sphere with antennas. It carried a simple radio transmitter, but its meaning was enormous. For the first time in history, a human-made object was orbiting Earth, not just flying upward, not just falling back down, orbiting, circling the planet again and again. Its radio signal could be heard around the world, a steady, haunting beep from above the atmosphere. To some, that sound was beautiful, the voice of a new age. To others, it was frightening. If the Soviet Union could place a satellite in orbit, then its rockets could reach far beyond what many had assumed. Sputnik changed the future overnight. It proved that space was no longer unreachable. It also proved that the competition had truly begun. A month later, the Soviet Union launched another mission. This time they sent a living creature, a dog named Laika. Laika became the first living creature to orbit Earth. Her flight proved that a body could survive launch and weightlessness at least for a time. But Laika did not come home. Her mission had no safe return. That fact gives her story a deep sadness. From the very beginning, space exploration was not only triumph, it was also sacrifice. Animals flew before humans because people did not yet know what space would do to the body. Some of them survived, some did not. Leica's journey showed both the courage and the cruelty of the early space age. She became a symbol of the cost hidden behind progress. Then came the moment when a human being left the planet. On April 12, 1961, Yuri Gagarin launched aboard Vostok 1. He became the first human in space. The flight lasted only 108 minutes, less than 2 hours. But those minutes changed human history forever. Gagarin completed one orbit around Earth. For the first time, a person was no longer looking up at the sky from the ground. A person was above it, looking back. Imagine that moment, the curve of Earth below, the darkness of space beyond, clouds moving across oceans, a blue world glowing beneath him. For all of human history, Earth had been the stage on which everything happened. The ground beneath our feet, the place of every war, every city, every language, every life. And now, for the first time, one human being had stepped outside that stage and seen it whole, not as a map, not as a globe, but as a living planet suspended in darkness. Gagarin's flight was a Soviet triumph, but it belonged to all humanity. It proved that human beings could survive beyond Earth. It showed that the boundary of our world could be crossed. After Gagarin, the United States moved quickly. Alan Shepard became the first American in space, with a short suborbital flight. John Glenn became the first American to orbit Earth. Each mission answered questions. Could a human launch safely? Could they function in weightlessness? Could they return alive? Could they control a spacecraft? Could they remain calm when the entire planet was watching? The Soviet Union continued to achieve major firsts. Valentina Tereshkova became the first woman in space. Alexei Leonov performed the first spacewalk, floating outside his spacecraft with only a suit separating him from the vacuum. Robotic probes reached the moon and other worlds. Each achievement raised the pressure. Each success made the next goal larger. And above all of those goals stood the moon. The moon had always been the brightest companion in the night sky, close enough to show phases and shadows, but still impossibly distant. It had guided calendars, inspired myths, shaped tides, and lit human nights for thousands of years. Now it became the greatest prize of the space race. In 1961, President John F. Kennedy gave the United States a challenge that sounded almost impossible at the time: land a human being on the moon and return him safely to Earth before the end of the decade. At that moment, Americans had barely reached space. The moon was hundreds of thousands of kilometers away. A lunar mission would require giant rockets, new spacecraft, navigation across deep space, life support, computers, landing systems, spacesuits, communication networks, and a way to bring the crew home. It was not one problem, it was thousands of problems stacked on top of one another. NASA began step by step. The Mercury program taught America how to send one person into space and bring them back. These early flights were short, dangerous, and limited, but they built the first foundation. Then came Gemini. Gemini was the bridge between Earth orbit and the moon. During Gemini, astronauts learned how to stay in space longer, how to maneuver their spacecraft, how to meet another spacecraft in orbit, how to dock, and how to walk in space. These skills were essential. To reach the moon, astronauts would not simply fly straight there and land like an airplane. They would have to separate spacecraft, dock them again, navigate across lunar distance, descend to the surface, lift off from the moon, meet the command module in lunar orbit, and return to Earth. Every step had to work. There was almost no room for error. Then came tragedy. In 1967, during a ground test, Apollo 1 caught fire. Astronauts Gus Grissom, Ed White, and Roger Chaffee were killed inside the spacecraft. They were not in space. They were not launching. They were on the ground. And still, spaceflight found a way to be deadly. The fire exposed deep problems in the spacecraft design, wiring, materials, hatch, and safety culture. It was a devastating moment for NASA. The dream of the moon suddenly became heavier. It was no longer only about glory or national achievement. It was about responsibility. Every wire mattered. Every switch mattered. Every design choice could decide whether people lived or died. NASA stopped, investigated, rebuilt, and redesigned. The Apollo spacecraft became safer because of the tragedy, but the cost was terrible. The road to the moon had already taken lives, and still, the mission continued. In December 1968, Apollo 8 carried humans farther from Earth than anyone had ever traveled before. Frank Borman, Jim Lovell, and Bill Anders flew around the moon. They did not land. But they did something almost equally powerful. They saw Earth rise above the lunar horizon. The photograph called Earthrise became one of the most important images ever taken. A small blue and white planet floating above the gray surface of the moon, surrounded by the blackness of space. It was beautiful, but it was also humbling. From that distance, Earth looked fragile, alone, borderless. Everything humanity had ever known was contained in that small sphere. Every ocean, every forest, every city, every person, every history, every hope. Apollo 8 showed us the moon. But more importantly, it showed us Earth. Then came July 1969. Apollo 11 launched from Earth on top of the massive Saturn V rocket. Neil Armstrong, Buzz Aldrin, and Michael Collins carried the hopes of millions of people with them. The world watched. The mission was incredibly complex. The spacecraft had to leave Earth orbit, cross the distance to the moon, enter lunar orbit, separate the lunar module, descend to the surface, land safely, and later return to orbit to meet the command module again. Michael Collins remained alone in lunar orbit aboard Columbia, while Armstrong and Aldrin descended in the lunar module Eagle. The landing was tense. The onboard computer gave alarms. The landing site was rougher than expected. Fuel was running low. Armstrong took partial manual control and guided Eagle toward a safer place. Then came the words, "The Eagle has landed." On July 20th, 1969, Neil Armstrong climbed down the ladder and stepped onto the lunar surface. It was a small movement of one human foot, but symbolically, it was enormous. For the first time, a living person stood on another world. A species that had once watched the moon from caves, deserts, forests, and villages had finally crossed the distance and touched it. Buzz Aldrin joined him. Together they walked in the dust, collected samples, planted instruments, took photographs, and left footprints that may remain for millions of years. The moon was no longer only a light in the sky. It was a place where human beings had stood. More Apollo missions followed. Astronauts returned to the lunar surface, explored different regions, gathered rocks, drilled into the ground, deployed scientific instruments, and eventually drove a lunar rover across the surface. They moved slowly through gray dust under a black sky. There was no wind, no sound outside their suits, no life, no weather, only the silence of another world. Every footprint stayed. Every track from the rover stayed. Every mark became a small human signature on a place that had waited untouched for billions of years. The Apollo missions brought back lunar rocks and data that changed our understanding of the Moon and Earth. Scientists studied the samples and learned about impact history, ancient lava flows, and the violent early period of the solar system. But after Apollo 17 in 1972, humans stopped going there. The reason was not that the moon had become easy. It was that the political goal had been achieved. The space race had reached its defining moment. Public attention shifted. Budgets fell. Priorities changed. Human beings had reached another world. And then, for decades, they did not return. But space exploration did not stop. It changed form. While humans remained closer to Earth, robotic spacecraft began traveling much farther than people could go. They became our eyes, our hands, and our messengers. Mariner missions explored Mars and Venus. Pioneer spacecraft traveled toward the outer planets. Viking landers reached Mars in the 1970s and sent back the first detailed images from its surface. Those images were quiet and strange. A rocky plain, a dusty horizon, a pale sky. Mars looked alien but also almost familiar. It had ground, stones, shadows, weather, and a horizon line. It was a real world, not a red dot, not a symbol, a place. The question followed immediately. Had Mars ever been alive? Mars had long lived in human imagination as a world of mystery. People once imagined canals, civilizations, deserts, and strange life beneath its reddish light. The real Mars turned out to be quieter, colder, and more lonely than those dreams. But it was not dead in a simple way. Its surface held clues of water. Its valleys looked carved by ancient flow. Its rocks carried memories of a different past. A past where rivers may have moved across the surface. A past where lakes may have existed. A past where the planet may have been warmer, wetter, and more Earth-like than it is today. Then came Voyager 1 and Voyager 2. These missions are among the greatest journeys in the history of exploration. Launched in 1977, the Voyager spacecraft took advantage of a rare alignment of the outer planets. This allowed them to fly from one world to the next, using gravity to change speed and direction. They visited Jupiter and Saturn. Voyager 2 continued on to Uranus and Neptune. For the first time, humanity saw the outer planets up close. Jupiter was not just a bright object in the night sky. It was a giant world of storms, bands, clouds, and immense power. Its great red spot was larger than Earth. Its moons were worlds of their own. Io had volcanoes. Europa had a cracked icy surface that hinted at an ocean beneath. Saturn's rings revealed astonishing structure, made of countless particles of ice and rock. Its moons were strange and diverse. Uranus appeared pale and tilted. Neptune was deep blue, distant, windy, and mysterious. Voyager showed that the solar system was not a simple collection of planets moving quietly around the sun. It was a family of worlds, each with its own personality. Moons could be geologically active. Ice could hide oceans. Distant places could be dynamic, complex, and possibly important in the search for life. And then Voyager kept going. After finishing their planetary encounters, the spacecraft continued outward. Far beyond the planets, they carried messages from Earth. golden records containing sounds, images, music, and greetings. Tiny traces of human civilization moving through interstellar space. There are greetings in many human languages. There is music. There are sounds of wind, thunder, birds, footsteps, heartbeats, and waves. There are images meant to describe our world, our bodies, our science, and our place in the galaxy. The chance that anyone will ever find the records is incredibly small, but that almost makes them more beautiful. They are not only messages to possible strangers, they are messages to time itself. Long after their instruments grow silent, Voyager 1 and Voyager 2 will keep traveling through darkness, carrying a memory of Earth away from the sun. In the 1970s and beyond, humanity also began learning how to live in space. This was a different challenge from reaching space. A launch lasts minutes. A mission may last days. But living in orbit for weeks, months, or longer means facing the slow effects of weightlessness and isolation. The Soviet Union built the Salyut stations and later Mir. The United States launched Skylab. These early space stations were laboratories, homes, and tests of human endurance. In orbit, the human body changes. Muscles weaken because they no longer have to fight gravity. Bones lose density. Fluids shift toward the head. Balance changes. Sleep becomes strange. The heart, eyes, immune system, and mind all adapt in ways scientists are still studying. Psychology matters too. Space is beautiful, but it is also confining. Astronauts live inside machines, surrounded by vacuum. Every breath depends on systems working correctly. Every drop of water, every meal, every movement must be managed. There is no stepping outside for fresh air. There is no open field, no ocean breeze, no simple walk beneath trees. Only metal walls, instruments, windows, and the constant knowledge that outside is a place where the human body cannot survive. Space stations taught humanity something very important. Visiting space is one thing. Staying there is another. In 1981, a new era began with the space shuttle. The shuttle looked different from earlier spacecraft. It launched like a rocket, operated in orbit, and returned like a glider. It was designed to be reusable, a spacecraft that could fly again and again. It seemed like the future had arrived. The shuttle launched satellites, carried astronauts, performed experiments, repaired spacecraft, and eventually helped build the International Space Station. It made spaceflight feel more routine than it had during Apollo. But spaceflight was never routine. On January 28, 1986, Challenger broke apart shortly after launch. 7 astronauts were killed. The disaster unfolded in front of the public, including school children who had been watching because teacher Krista McAuliffe was aboard. The tragedy shocked the world. It reminded everyone that even after many successful missions, one failure could destroy everything in seconds. Years later, in 2003, Columbia disintegrated during re-entry. 7 more astronauts were lost as the shuttle returned to Earth. Again, the lesson was painful. Space is unforgiving. A small piece of foam striking the wing during launch could lead to catastrophe days later. A tiny weakness could become fatal when a spacecraft hit the atmosphere at enormous speed. The shuttle era achieved many remarkable things, but it also showed the cost of underestimating risk. Every launch is controlled fire. Every orbit is a fall around the planet. Every re-entry is a controlled return through a wall of heat. Spaceflight may become more advanced, but it never becomes simple. While human missions captured the imagination, satellites were quietly transforming everyday life. Most people did not think about them. But above their heads, machines in orbit were changing the world. Satellites carried television signals and phone calls. They helped forecast weather, track storms, monitor forests, map cities, measure climate, guide ships, support military systems, and later make global navigation possible. Space became invisible infrastructure. A person could check the weather, use GPS, watch live broadcasts from across the planet, or communicate over long distances because machines were circling Earth in silence. The space age was no longer only about astronauts and rockets. It had entered daily life. It was in the phone, in the weather report, in the airplane route, the airplane, in the emergency signal, in the photograph of a hurricane before it reached land, in the quiet navigation voice telling someone when to turn. Space had become part of Earth. Then, in 1990, the Hubble Space Telescope was launched. At first, Hubble was a disappointment. A flaw in its mirror made the images blurry. It was a painful mistake, especially for such an expensive and ambitious telescope. But because Hubble was in low Earth orbit, astronauts could reach it. They flew to the telescope, repaired its vision, and gave humanity one of the greatest scientific instruments ever built. After the repair, Hubble transformed our view of the universe. It showed nebulae where stars are born, galaxies colliding and spiraling, dying stars surrounded by glowing shells of gas, deep fields filled with thousands of galaxies in tiny patches of sky. Hubble made the universe feel both more distant and more intimate. It showed that space was not empty darkness. It was structure, light, color, dust, gravity, time, and creation on scales almost impossible to imagine. The telescope did not take us physically farther from Earth, but it took human sight billions of years into the past. In one tiny patch of sky, Hubble revealed thousands of galaxies. Each galaxy held billions of stars, and many of those stars may have planets. A small, dark piece of sky, once thought almost empty, became a window into cosmic history. That is one of the strange gifts of astronomy. The more carefully we look at emptiness, the less empty it becomes. After the Cold War, space slowly became less about direct rivalry and more about cooperation. The greatest symbol of this shift was the International Space Station. The ISS was built by many nations working together: the United States, Russia, European countries, Japan, Canada, and others. Piece by piece, module by module, it became one of the most complex structures humanity has ever created. It circles Earth at roughly 28,000 kilometers per hour. The crew sees many sunrises and sunsets in a single day. Inside the station, astronauts conduct experiments in biology, medicine, physics, materials science, climate research, and technology. They study how the human body changes in space. They grow plants. They test systems that may someday help people travel farther. But the ISS is more than a laboratory. It is proof that space can bring nations together. On Earth, borders divide people. In orbit, the planet has no lines. Only land, ocean, clouds, deserts, ice, and atmosphere. The station became a small human outpost in the darkness, a place where people from different nations lived and worked together above the world. There is something deeply symbolic about that. A structure made of metal, wires, solar panels, computers, air, water, and human trust. A home that is always falling around Earth. A laboratory that exists because many countries chose to build something together in the most difficult environment humans have ever worked in. Meanwhile, robotic explorers kept traveling. Mars became one of the central targets of modern space exploration. The planet had always fascinated humanity. It was close enough to see with telescopes, red enough to feel mysterious, and Earth-like enough to inspire questions. Did water once flow there? Was it ever warmer? Could life have existed? Spirit and Opportunity landed on Mars and explored the surface. Opportunity, designed for a mission of about 90 Martian days, survived for years. It crossed plains, studied rocks, and found evidence that water had once shaped the planet. Curiosity landed later and explored ancient environments, studying sedimentary rock and chemistry. It found signs that Mars once had conditions that could have supported microbial life. Perseverance arrived with another goal: to search for signs of ancient life and collect samples that may someday be returned to Earth. And then there was Ingenuity, a tiny helicopter. It was only a technology demonstration, but it became the first aircraft to make powered, controlled flight in the atmosphere of another planet. That achievement was quiet but extraordinary. More than a century after the Wright brothers flew on Earth, a small machine lifted into the thin air of Mars. Mars changed in human imagination. It was no longer only a desert planet. It became a world of ancient rivers, lake beds, dust storms, cliffs, craters, and unanswered questions. The rovers made Mars feel near. They moved slowly, sometimes only meters at a time, across a world millions of kilometers away. They stopped to look at rocks. They drilled. They photographed. They listened to commands sent from Earth across empty space. Each wheel track was a sign that human curiosity had reached another planet, even before human footsteps did. Other missions explored even farther. Cassini spent years studying Saturn, its rings, and its moons. It revealed Titan as a world, with thick atmosphere, methane lakes, rivers, and weather. It found Enceladus spraying water-rich plumes from beneath its icy surface, hinting at a hidden ocean below. That discovery was astonishing. A small icy moon, far from the sun, might have liquid water beneath its crust. And where there is water, energy, and chemistry, the question of life appears again. Galileo and Juno studied Jupiter. New Horizons flew past Pluto in 2015 and revealed a world far more complex than expected, with mountains of ice, smooth plains, strange geology, and a thin atmosphere. Pluto had once been imagined as a frozen, almost featureless body at the edge of the solar system. New Horizons showed it as a real world. Strange, beautiful, active. The more humanity explored, the more the solar system surprised us. Almost every world turned out to be more complicated than expected. No planet was just a point of light. No moon was just a simple rock. Everywhere we looked closely, we found structure, movement, history, and mystery. Then came a new shift in the 21st century. For most of history, spaceflight belonged almost entirely to governments. Only nation-states had the money, infrastructure, and power to build rockets and send people or spacecraft beyond Earth. But private companies began entering the field. They built rockets, spacecraft, satellite systems, launch services, and new technologies. The most dramatic change came from reusability. For decades, rockets were mostly used once. A rocket would launch, stage by stage, and much of it would fall away or be destroyed. This made reaching space extremely expensive. But if part of a rocket could return, land, and fly again, the economics of spaceflight could change. SpaceX became the clearest symbol of that new era. The sight of a rocket booster descending from the sky, firing its engines, and landing upright on a pad or drone ship became one of the defining images of modern spaceflight. It looked almost unreal. A machine that had just helped launch payloads toward space returned to Earth and stood again like a tower. Crew Dragon later carried astronauts from American soil to the International Space Station, restoring a capability the United States had lost after the end of the shuttle program. Other companies developed their own systems as well. Some focused on launch, some on satellites, some on space tourism, some on lunar landers, stations, or future infrastructure. Space was no longer only a contest between superpowers. It was becoming an economy. Thousands of satellites began to fill orbit. Internet from space, Earth observation, commercial research, private missions, and new launch markets became part of a rapidly changing landscape. This brought opportunity, but it also brought danger. Earth orbit is getting crowded. Every satellite, rocket stage, fragment, and piece of debris becomes part of the environment above our planet. Even a small object traveling at orbital speed can hit with devastating force. A screw, a shard of metal, or a paint fleck can become dangerous when moving many kilometers per second. Space debris threatens satellites, crewed stations, telescopes, and future missions. If orbit becomes too crowded and too polluted with debris, certain regions could become difficult or even dangerous to use. Humanity is learning that space is not infinite in the practical sense. The useful space around Earth must be protected. Exploration now requires responsibility. The question is no longer only how to reach space. It is how to use space wisely, how to share orbit, how to avoid turning the sky into a junkyard, how to make sure the next generations can still launch safely, communicate, explore, and look outward. At the same time, science kept opening new windows. The James Webb Space Telescope became one of the most powerful observatories ever placed beyond Earth. Unlike Hubble, Webb observes mainly in infrared light. This allows it to see through dust, study the birth of stars, analyze the atmospheres of planets around other stars, and look back toward some of the earliest galaxies in the universe. If Hubble gave humanity a deep and beautiful view of the cosmos, Webb is helping us see even further into its ancient past. It is not only showing us objects, it is showing us time. Light from distant galaxies has traveled for billions of years before reaching the telescope. When we look far enough away, we are looking backward. The universe becomes a history written in light. Webb also helps study exoplanets, planets orbiting stars beyond our sun. For most of human history, no one knew whether other stars had planets at all. People imagined them, but imagination is not evidence. Then the discoveries came. First a few, then hundreds, then thousands. Now we know that planets are common. Some are gas giants larger than Jupiter. Some orbit extremely close to their stars. Some are rocky. Some may exist in regions where liquid water could survive on the surface. The question changed. It was no longer, are there planets around other stars? Now it became, how many worlds are out there? How many might be like Earth? How many could have oceans, atmospheres, chemistry, or life? And the oldest question returned in a new form. Are we alone? No mission has answered that yet. But for the first time, humanity has tools powerful enough to begin searching in serious ways. We can study the light passing through alien atmospheres. We can look for chemical fingerprints. We can search for worlds where clouds, heat, water, and chemistry might create conditions that remind us of home. We do not know what we will find, but the search itself changes us. It reminds us that Earth may be rare, or it may be one world among many living worlds. Either answer would be profound. Today, human attention is turning back toward the moon. The Artemis program aims to return people to the lunar surface. But this time, the goal is different from Apollo. Apollo was about reaching the moon. Artemis is about learning how to stay. The moon may become a proving ground for deep space exploration. It is close enough for missions to reach in days, but harsh enough to teach lessons that will matter for Mars. There is no breathable air, no liquid water on the surface. Radiation is a serious danger. Temperatures swing between extremes. Lunar dust is fine, sharp, and difficult. Every habitat, rover, suit, tool, and power system must survive in an unforgiving environment. If humans can learn to live and work on the moon for longer periods, they will gain knowledge needed for the next great step. Mars. Mars remains the dream that pulls on the future. A crewed journey to Mars would be unlike anything humanity has ever attempted. The trip would take months. The astronauts would be far beyond quick rescue. Communication delays would make real-time conversation with Earth impossible. Radiation would be a constant concern. Landing large payloads on Mars is extremely difficult. Producing fuel, water, oxygen, and shelter would be essential for long-term missions. And then there is the human mind. A Mars crew would live in isolation for a very long time, farther from home than any humans before them. Earth would no longer fill the window. It would become a bright point in the sky. The psychological weight of that distance may be as great as the technical challenge. And still, the idea remains powerful. To stand on another planet. To see a sunrise through a dusty Martian sky. To look at Earth as a star. That dream has not gone away. It has survived war, failure, tragedy, budget cuts, delays, disasters, and doubt. Because Mars represents more than a destination. It represents the next question. Can humanity become a species that lives beyond Earth? Not just visits. Not just plants a flag, but truly learns to survive somewhere else. That question is enormous, and it will not be answered quickly. The history of space exploration is not a clean, straight line of victories. It is a story of wonder and fear, science and politics, genius and accident, courage and sacrifice. It began with people looking at the stars and trying to remember their patterns. It moved through philosophers, astronomers, telescopes, mathematics, and the discovery of gravity. It passed through fireworks, weapons, rockets, war, and rivalry. It sent machines into orbit, animals into danger, humans beyond Earth, and footprints onto the moon. It built stations above the planet. It sent robots across Mars. It flew spacecraft past Jupiter, Saturn, Uranus, Neptune, and Pluto. It placed telescopes above the atmosphere and looked back toward the beginning of time. And through all of this, space changed the way humanity sees itself. From the ground, Earth feels endless. Continents are vast. Oceans seem immeasurable. Mountains feel eternal. Human conflicts can feel enormous. Borders can seem permanent. Nations can seem like the largest things in existence. But from space, Earth looks different. There are no lines drawn between countries, no visible walls between people. Only a blue planet wrapped in clouds, protected by a thin layer of atmosphere so delicate that it seems almost impossible that everything alive depends on it. That view may be one of the greatest gifts of the space age. We left Earth to discover the moon, the planets, and the stars. But in the process, we discovered Earth again. We saw that our home is not just the ground beneath us, it is a small world in a vast darkness. Beautiful, fragile, alive, and the story is not finished. Right now, satellites are orbiting overhead. Some are helping people navigate. Some are watching storms. Some are studying the climate. Some are connecting people across oceans and continents. Astronauts are living and working in orbit. Rovers are moving across Mars. Telescopes are looking into deep space. Old spacecraft are still traveling outward, silent messengers from a small blue world. Engineers are designing new rockets. Scientists are studying distant planets. Missions are being planned for the moon, Mars, icy moons, asteroids, and beyond. Somewhere, a child is looking up at the night sky and asking the same question humans have always asked. What is out there? Long ago, our ancestors looked at the stars without knowing what they were. Then we learned their patterns. Then we measured their motions. Then we discovered gravity. Then we built rockets. Then we left Earth. And still, after all this, the universe has not become smaller. It has become larger. Every answer opens another question. Every world reveals another mystery. Every mission shows us that space is not empty, but full of stories waiting in silence. Maybe that is why humanity keeps going. Not because space is easy. Not because it is safe. Not because we fully understand what we will find, but because something in us has always looked toward the horizon. First, the horizon of the land, then the horizon of the sea, then the horizon of the sky, and now the horizon of the stars. The history of space exploration is the history of humanity slowly learning that the universe is bigger than fear, bigger than borders, bigger than one generation, bigger than one world. And maybe somewhere far in the future, when people walk beneath another sky, on another world, around another star, they will look up too, and they will remember that it all began here, with Earth, with the night, with silence, with wonder, and with the simple act of looking up.